Hello, let us start a series lecture on number system. We'll start with finding the LCM and HCF of some numbers, a pair of numbers, say 72, 124. Write the numbers. Take the difference between the numbers, that comes to be 52. Now, this 52 multiplied by some number should give us the answer 72. To get the answer as 72, we have to multiply this by some number. We see that it is a fraction and it is not a whole number. For simplification, let us take it to be 72 by 52 itself, so that 52 and 52 cancels and we get back 72. We will simplify this ratio further. This becomes 36 by 26 or 18 by 13. Now this is the simplest form. Always the simplest form of this fraction has to be taken. Then the difference divided by the denominator of the simplest form of the fraction gives us the HCF. HCF is 52 divided by 13, and that is 4. Now the LCM is the numerator 18 multiplied by the second number 124. 18 multiplied by 124, and 18 multiplied by 124 can be written as 124 times 20 minus 2. 20 minus 2 is 18, and 124 into 2 is 248 and 100. 124 into 2 again 248. The difference will become 2 3 2 2 2 2 3 2. This is the LCM and this is the HCF. The difference divided by the denominator is the HCF. The numerator multiplied by the second number gives us the LCM. Coming to the next question, find the LCM and HCF of 26, 24, 28 and 30. Now write each of these numbers in terms of prime numbers, that is called as prime factorization. 26 can be written as 2 into 13. 24 can be written as 2 into 2 into 2 into 3, that is 8 into 3, or this is 2 cube into 3. 28 is 2 into 7, or 2 square into 7. 30 is 2 into 3 into 5. Now from these numbers, pick up what comes common in all three factorizations. You see that 2 ones comes common in all four factorizations. Once 2 appears common in all four, so 2 becomes the HCF. And now the LCM. Pick up all the prime numbers that you see. I see 2, then 13, 3, 7 and 5. All these numbers, pick the highest power of these primes observed. The highest power of 2 is 3, highest power of 13 is 1, highest power of 3 is 1, highest power of 7 1, and 5 1. This multiplied gives us the LCM, that is 2 cube into 3 into 5 into 7 into 13. And now this product has to be done. 13 into 7 should be 91, into 5 should give us 455, and 2 cube into 3, 455 into 3 should be 400 into 3, 1200, 55 into 3, 165, that becomes 1365, and 1365 multiplied by 8, still we have 8 remaining. So 1365 multiplied by 8 I can take it as 10 minus 2, and 1365 into 10, 13650, 1365 into 2, I am left with 1365 into 2 should be 3027. Okay, 2730. Now the difference 0, 2, 16 minus 9 and 10. 10920 is the LCM. Let us proceed to the next type of question, that is finding the last digit of 122 power 43 into plus 128 power 48. To find the last digit, we will find the last digit separately and then find the last digit of the sum. 122 power 43, take the last digit forward 2 and the power, take it separately, 43. Divide this by 4. Always divide the power by 4 irrespective of whatever last place you have. Whatever be the base, whatever be the power, still divide it by 4 and take the remainder. Now take this number forward and the remainder being 3, take 2 to the power 3. So it is 2 power 3. Whatever 2 power 3 ends with is the same number that 122 power 43 will end with. 2 power 3 is 8, ends with 8 itself, and we proceed to the next part. 128 power 48. So 128 to the power 48, the power divided by 4, remainder, and the last place taken forward 8, and the remainder here is 0. Whenever we have a remainder 0 when divided by 4, it is same as remainder 4. Always take to the fourth power, do not take the power 0. Then whenever you have 0, you have to replace it with 4. 8 power 4 ends with 8 square ends with 8 square is 64 and 4 into 4 is 16, so it ends with 6. 8 power 4 ends with 6. Now this number ends with 8 and this number ends with 6, so the sum should end with, the sum is going to end with 4, which is our required answer. The next type of question, a number n divided by 52 gives a remainder 26. Find n divided by 13 remainder. We do not know what the number is, but still this can be found. For this condition, for this question, if you have to get an answer for this kind of question, then there is one particular condition which says this number 52 should always be a multiple of 13. Otherwise, the question doesn't have sufficient data to be solved. So we know that 13 multiplied by 4 gives us 52, and 52, since it is a multiple of 13, this question can be solved, and the answer is, take this remainder ahead 26, divide it by 13 and take the remainder. Whatever remainder that you get here is the same number you would get when you divide this number by 13 and the remainder. 26 by 13 remainder is 0, so the remainder when n is divided by 13 is also 0. That is the answer. We will proceed to the next type of question. Find the remainder when 2 power 92 is divided by 92. To solve this question, we will consider the powers of 2 and check how close they are to the 92. So to check if any of the power of 2 is close to a multiple of 92, we go with this method. Write the first power of 2, 2 power 1, and since we are dividing by 92, and we will also write, it gives the remainder is 2 itself, and we will write the reminders here and powers here. This is a sort of a tabular column that we are going to make use of. Now the first power of 2 when divided by 92 gives a remainder 2 itself. Next, because we are taking the power of 2, the remainder, just multiply it by 2. 2 into 2 gives me 4, and this becomes the power. Synchronize it. This is the first place, second place, and proceed like that. Now 4 divided by 92 also gives me a remainder 4, then into 2 gives me 8, again a remainder 8, then 16. The number has to cross 92 to give you a different remainder. And 8 2s are 16, remainder 16, 32, remainder 32, then I have 64 and remainder 64, then we have 128. 128 divided by 92 should give us a remainder 36. Then again we proceed, 36 into 2, 72, and again the remainder is 72. 144, this will give us a different remainder, that is 52. Into 2 should give us 104, and the remainder now is 12. And proceeding further, we have 12 into 2, 24, and it gives a remainder 24 itself. And into 2 should give us 48. 48 itself is a remainder. Into 2, 96, and the remainder is plus 4. Now there is something important to note here. The important being the remainder that you got at some particular place previously is being repeated again. When the remainder repeats, it will follow a particular sequence, and the numbers in between, that is after this particular place, you will again have 4. After 4 you will have 8, 16, 32, 64. The same sequence will keep repeating n number of times, and for that what we do, we count the place for which we got the remainder repetition. That is, this is the first place is 2, 1, this is 2, third power, fourth power, fifth power, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13. It is the 13th place, that is 2 to the power of 13 gives me a remainder of 4 when divided by 92. Now to simplify this question, we will take it as 2 power 92 will be written as 2 power 13 whole power 7, which accounts for 2 power 91, and into 2 will make it 2 power 92. This has to be written as 2 power 91 into 2 by 92 whole remainder. Now 2 power 13 gives me a remainder 4, and we know it from this tabulation, and so I will take it as 4 directly. And again I am left with 4 power 7 into 2 divided by 92 whole remainder. And here there is another important observation to make. 4 power 7 divided by 92, since we have tabulated already for the powers of 2 till the 13th place, let us take it as 2 power 2 whole power 7. Then it becomes 2 square whole power 7 into 2. 2 square is 4. 2 square power 7 is 2 power 14 into 2, or 2 power 14 into 2, which can be written as 2 power 13 into 2 square. Now this divided by 92 remainder. We know that 2 power 13 will give us a remainder of 4 from the table. So that is why I split up. I removed 1 2 from this and moved it to the 2 square part. 2 power 13 divided by 92 gives a remainder 4. So 4 into 2 square, that is 4 divided by 92 remainder, which is 16 by 92, and remainder is 16 itself. Moving to the next type of question. Let us find the remainder when 3 power 76 is divided by 5. Now we need not go for the sequence with powers of 3. There is a different method when the numbers are small, when the denominator is smaller. That is based on the binomial theorem, and the method works like this. This numerator 3 has to be written in terms of 5. To write 3 in terms of 5, we have to write it as 5 minus 2, and it is 3. Take 5 minus 2 to the power 76, divide by 5, and then the remainder. When you see a number that is a multiple of the denominator in the numerator, when expanded like this, simply erase this and proceed with the remaining. So 5 is removed, and this becomes 2 power minus 2 power 76, which is same as plus 2 power 76, because a negative number to an even power will give you a positive answer. Minus taken even power will give you plus. 2 power 76 can be further written as 2 square whole to the power 38 and divided by 5 remainder, that is 4 divided by 4 power 38 divided by 5 remainder. 4 can be written as 5 minus 1, so let me write it as 5 minus 1 power 38 divided by 5 remainder. In this I see something common again, so I remove the 5, and minus even power will become plus, so 1 power 38 is 1 by 5 remainder, which is 1 itself. So the answer for this calculation, 3 power 76 by 5 remainder, should be 1. So moving to the next type of sum. What is the highest possible value of x that gives a whole number answer to the calculation 343 factorial divided by 7 to the power x? Now in this value 343 factorial, it is 343 into 342 into 341 and so on till say 3 into 2 into 1 till 1. This is what factorial means, and in this we have many values that are multiples of 7. All of them will lead to all of them have to be eliminated, and the number of times 7 appears in this series is the maximum value of x that is possible. And to do that, there is a very simple method. You divide 343 by 7 and you do the normal division. 7 4s are 28, remaining is 63, 7 9s are 63, we don't have a remainder here. 7, this 49 that we got as the quotient has to be further divided by 7, that gives us 7 7s are 49, and this quotient again has to be divided by 7, 7 1s are 7. You have to keep continuing this till the quotient becomes smaller than the number with which you are dividing. So all these three terms are the quotients that I have got till now, and these three terms added will give us the maximum possible value of x. Now it is 49 plus 150 plus 757. The maximum possible value for x is 57, and even say a power of 7 more than 57 will not be giving me an integer or a whole number as the answer. Moving to the next type of question. How many zeros does the value of 220 factorial end with? Now to find out the number of zeros, it is similar to finding a question. It is a simple question to be solved, where you consider that, say, if you divide 220 factorial by 5 to the power x, the maximum possible value that can be assigned to x is the number of zeros that you will find in 220 factorial. Always take it as 5, because every 5 that you come across and every multiple of 5 that you come across in 220 factorial is the contributing factor to a 0, and every second power of 5 will contribute to 2 zeros. Every third power of 5 will contribute to 3 zeros in this factorial. Hence, divided by 5 power x, you get the maximum possible value of x, which itself is the number of zeros. So this method is simple. Divide it by 5. 5 4s are 20, and again I have 20, so 4s are 20. So 44 is divided by 5 again. 8s are 40. I have a remainder. Do not bother about the remainder. Just proceed with the quotient. 8 divided by 5, so 5 1s are 5, and it is remainder 3. Now the quotients put together, it is 44 plus 8 plus 1, that is 52 plus 1, 53. Now when this value is calculated and written as a number, which will be a really huge number, it will have 53 zeros at the end. The next question: how many factors does the number 242 have? To find the number of factors, we have to write this number as a prime factorization. we have to use prime factorization, split up this number and write it. So 242, it is not 243, 242 can be written as 2 into 121. We see that 121 is a multiple of 11, so 2 into 11 into 11, that is 2 into 11 square. Now this is the prime factorization of 242, and here what we have to do is all the prime numbers, their powers should be selected. Here the power of 2 is 1 and power of 11 is 2. Pick up these powers 1 and 2, add 1 to both the numbers and multiply these two values. If there are more than 2, you have to multiply all the values. This becomes 2 into 3, which is 6. The total number of factors the number 242 has is 6. Let us learn something about the divisibility rules, and this is about finding the divisibility rules. Broadly, the numbers for finding the divisibility rules can be classified into 3 prime categories. The first category being powers of 2 and 5, like the number 2 itself, 4, 8, 16, 32, 64 and so on. The powers of 5 being 5, 25, 125, 625 and so on. And for this particular category of numbers, the method is whatever be the number, whatever be the number of digits it has, you need not be bothered about the number. That is, say the number is 1, 2, 3, 4, 5, 6, and you want to check if this number 1, 2, 3, 4, 5, 6 is divisible by some value among these, say 8. If you are checking by 8, you should know that it is the third power of 2, so the last 3 places of this number is what I have to check. If you are checking with 32, it is the last 5 places that I have to check, since it is the 5th power of 2. If you want to check if this number is divisible by 125, you have to check the last 3 places, since 125 is the third power of 5. Divisibility by 25, you have to check the last 2 places, since it is the second power of 5. And this is the method used for powers of 2 and 5. Now the next category is the prime number category. The prime number category of numbers has a particular way of finding a sequence, one particular sequence. So say if the number is 1, 2, 3, 4, 5, 6 and you want to check if this number is divisible by 7, then this particular sequence 1, 3, 2, minus 1, minus 3, minus 2 is written below the number, and you multiply the corresponding places. 6 into 1 is 6, 5 3s are 15, 4 into 2 8, 3 into minus 1 is minus 3, these are plus, 2 into minus 3 is minus 6, 1 into minus 2 is minus 2, and this thing summed up will give us 6 plus 5 21, 21 plus 8 is 29, 29 minus 3 26, 26 minus 6 20, minus 2 is 18. So this should be equal to 18. If the answer that you get is either 0 or a multiple of 7, then this number 1, 2, 3, 4, 5, 6 will be a multiple of 7. So this is a method of simplifying it. Now when we do not know this sequence, how do we generalize it for all the prime numbers? To find this particular sequence, the method is write 1, divide 1 by 7, 7 zeros are 0, remainder 1, just add a 0. The first place I got remainder as 1, write it aside separately. Next 7 ones are 7, I get a remainder 3, write it here, add a 0. 7 fours are 28 and remainder 2. I am not bothered about the quotient, so I need not write it, and this should be remainder 2. Now 20, this gives me 7 twos are 14, remainder plus 6, which is equivalent to remainder minus 1 when divided by 7. Always take the remainder positive or closest to 0 as possible. Now minus 1 is closer to 0 than 6 is. So I am considering minus 1 instead of 6. The next place I will be writing minus 1. Now add a 0 here and 7 ones are 7. You get a remainder minus 3. Write it minus 3 and minus 30. 7 4s are 28 and you have minus 2 left. And again minus 20. 7 3s are 21. You have plus 1 plus 1. And when you get one number repeated, 1 comes back here, then the rest will also repeat and it forms a sequence. Similarly, a sequence for 13, 17, all the other numbers can also be found. This method works with the powers of 3 also. So powers of 3, that is 3, 9, 27. Finding the divisibility rules for these numbers also can be done by this method. And for 3 it happens to be that the sum of numbers should be divisible by 3. For 9 it is that sum of numbers should be divisible by 9, because the remainder sequence that they give is just 1 1 1 1 1. For 11 the remainder sequence that you get is 1 minus 1 1 minus 1 and alternately. So you add up the first, third, fifth, seventh number and the second, fourth, sixth, eighth number. Take the difference between the sums. If the difference is 0 or a multiple of 11, the whole number should be divisible by 11. Now the third category of numbers, I call it as composite numbers. This composite type of numbers are those numbers which do not come under these two categories. Say 6 does not come under this category, 10 doesn't come, you have 12, you have 14 and all these numbers. Now any of these numbers has to be split and written as a product of two numbers. 6 has to be written as a product of two numbers. Do not take 1 into 6, we can take it as 2 into 3. 10 can be written as 5 into 2. Now then after writing it as a product of two numbers, you have to check if the number we were checking for 1 2 3 4 5 6, if this number is divisible by both 2 and 3. If it is, then the whole number is divisible by 6. Now to check for this number to be divisible by 2, the last place should be either 0 or 2 4 6 8 or an even number in general. So this is an even number, so it is divisible by 2. And to check by 3, sum should be divisible by 3. The sum becomes 11, 15, 18, 20, 21. So this sum is also divisible by 3. Hence the number is divisible by both 2 and 3, which implies the number is divisible by 6 also. Now say when we take example of another number 12, to check if a number is divisible by 12. To split it up, you can split it up as 2 into 6 or 4 into 3. Now when you split it up in terms of these factors 2, 6 or 4, 3, you have to select that pair which is a co-prime pair. A co-prime pair means that you should not have a common factor for the two numbers selected other than 1. If you select 2, 6, they are not a co-prime pair, because both are divisible by 2, a number other than 1, and we have to ideally select 4 and 3. When the number 1 2 3 4 5 6, say 1 2 3 4 5 6 is divisible by both 4 and 3, then it is divisible by 12. If we have to check it to be divisible by 4, it should be divisible by the last two places. Sorry, the last two places should be divisible by 4. Now 56 divided by 4, which is, yes, 56 is divisible by 4, that is 14 into 4 gives us 56, and to be divisible by 3, the sum, which is 21, is divisible by 3. Hence the number 1 2 3 4 5 6 is divisible by 12 also. If you want to check if a number is divisible by 33, say, split it as a product of two numbers, that is 11 into 3, and they are co-prime. You have to just check if this number is divisible by both 11 and 3. If it is, then it is divisible by 33. If it is not, then it is not divisible by 33. Thank you. That ends the video on number series.